Okay, number 12, baking soda, sodium bicarbonate, is a compound commonly used in baking goods as a deodorizer in refrigerators and as an antacid. Commercial quantities of baking soda are produced by mixing soda ash dissolved in water with carbon dioxide. Baking soda precipitates as a solid from this method. And then we're given the balanced equation here. We know it's balanced because we've got a 2 in front. So it says that it's made by mixing soda ash, dissolved water, and carbon dioxide together. So these are all of our reactants. And you should know that this is carbon dioxide and you should know that this is water, which means that tells you that this is the formula for soda ash. And then it says baking soda precipitates as a solid from this method, which means that it's made, okay? So here's our product. It also says that baking soda is produced. So here's baking soda's formula. And it says how many grams of soda ash would be needed to produce 1 kilogram of sodium bicarbonate. Okay, so remember sodium bicarbonate is baking soda. That's this formula here. And that we're trying to figure out how many grams of our soda ash, Na2CO3, we would need to be able to do this. Okay, so given is 1.00 kilograms of sodium bicarbonate in NaHCO3. Now, the first thing you need to know is that kilograms is 1,000 grams. So this is pretty easy. 1 kilogram really means that we have 1,000 grams of the same thing. All right, and we're looking for how much soda ash we would need. So the soda ash is Na2CO3. And obviously that's grams. Okay. So how to get from baking soda into soda ash and grams to grams. So that means that we're going to go from grams of NaHCO3 into moles of NaHCO3 into moles of Na2CO3 and then last into grams of Na2CO3. Okay, so that means that we've got 3 different conversions we have to do. Remember, whenever you go from mass to mole or mole to mass, that's molar mass. Whenever you go from mole of one substance to moles of the second substance, it's coefficients, mole ratio, and then this is another molar mass because we're going from moles of soda ash into grams of soda ash or sodium carbonate. Okay, so our first equivalent statement, we've got 1 mole of NaHCO3 equals blank grams of NaHCO3. So that's 1 times sodium, 1 times hydrogen, 1 times carbon, and 3 times oxygen. So 1 times 22.990. 1 times 1.008, 1 times 12.011, and 3 times 15.999. So that's 22.990 and 1.008 and 12.011 and 47.997. And we have to add all those up. And that gives us 84.006. And put that in our blank. So there's the molar mass of sodium bicarbonate. And then we need to go from moles of sodium bicarbonate into moles of soda ash or sodium carbonate. So that's moles of NaHCO3 equals blank moles of Na2CO3. So for this, we have to look back at our balanced equation for our coefficients. So there's a 1 in front of the Na2CO3, and there's a 2 in front of the NaHCO3. So we have 2 moles of sodium bicarbonate and 1 mole of sodium carbonate or soda ash. Okay, and then the last step is to do our molar mass of sodium carbonate or soda ash. So 1 mole of Na2CO3 equals blank grams of sodium carbonate. So that's 2 sodiums, 1 carbon, 3 oxygens. So that's 2 times 22.990, 1 times 12.011, and 3 times 15.999. So 2 times 22.990 equals 45.98, and 12.011 because we only have one of them, and 3 times 15.999 is 47.997. So when we need to add all those up, and we get 105.988, and put that in a blank. Okay, so our equation, this is a 3-step. Okay, we're starting with grams of NaHCO3. We're going to moles of NaHCO3. And then we're going into moles of Na2CO3. And then into grams of Na2CO3. Remember that this here is just our mole map. Grams, moles, moles, grams. And we need our units to cancel out. So if we have grams of sodium bicarbonate on top, we need the same thing on bottom. Grams of NaHCO3. And here we have moles of sodium bicarbonate, which means we need moles of sodium bicarbonate on bottom. Moles of NaHCO3. And then last, we've got moles of sodium carbonate or soda ash. We need moles of soda ash on bottom. Na2CO3. Okay, so then substituting in to solve, we're given 1,000 grams of NaHCO3. Okay, and remember it's always 1 mole for your molar mass. And then we take our molar mass of sodium bicarbonate, which is 84.006 grams of NaHCO3. And then we go for our mole to mole ratio. So that's 1 mole of Na2CO3 for 2 moles of our baking soda, NaHCO3. And then last we use our molar mass. So that was 105.988 grams of Na2CO3 over 1 mole of Na2CO3. Okay, so what are we doing math-wise? We're taking our 1,000 grams, we're dividing it by 84.006, dividing by 2, and then multiplying by 105.998. And we get, we equal 630.836. That's with some rounding there. Okay, so now significant digits. If we look back back up with what we were given. We were given 1.00 kilograms. So even though it's not written that way on here, this really should have 3 significant figures as well. So technically the way that you would write that to 3 significant digits is you would write it as 1.00 times 10 to the third. That'd be the best way to write it, but I was just being quick and throwing it in there. Alright, so our next one, the 84.006, has 5. Our molar ratios are always exact. And then our last molar mass has 6. So our answer needs to go to 3 significant digits. So we round off to the 0, and the 8 rounds the 0 up. So this becomes 631 grams of Na2CO3. Alright, 13. This is a very quick and easy problem. So in this it says you've got a reaction of A plus B yields C plus D, and it says if element B is in excess, which substance is a limiting reactant? Well, very simply, if your B is in excess, then A has to be limiting, because it's the only other reactant you have. Okay, so remember these guys here are the reactants. These guys here are your products. Remember, always to the right of the arrow is the products, always to the left of the arrow is the reactants. So that's easy enough. Next one. Another easy question, what's the safest practice when mixing water and acid? So there's 2 ways you can remember this. You can either remember A&W root beer, or you can remember the phrase, do what you oughta. Put the acid in the water. So, either one, A&W root beer, A to W, or do what you oughta, put the acid in the water. Either way, it's add acid to water. Never the other way around.